In 2014, a geneticist named Emilia Huerta-Sánchez was looking at a stretch of human DNA that refused to behave the way it was supposed to. She and her colleagues had been studying a single population, a people who live where the human body, by every ordinary rule, is not built to survive. Higher than most clouds form, on a plateau that sits more than 4,000 meters above the sea, where the air holds close to 40% less oxygen than it does down at the coast. A healthy person from the lowlands who travels up to meet them feels it within hours. The headache first, then the breathlessness, the nausea, the strange heaviness in the chest. Stay too long, too high, and the body can begin to fail, the blood thickening, the heart straining in a slow and dangerous protest against the thinness of the air. And yet, these people do not merely survive up there. They farm, they herd, they raise children. They have lived on that plateau generation after generation for thousands of years, as if the punishing height were simply home. When Huerta-Sánchez looked into their DNA, she found the reason written into a single gene. One short instruction that seemed to hold the secret of how a human body can be at peace with so little air. The strange part was not that the gene existed. The strange part was where it came from. Because when the team searched the rest of the living human species for a match, every other population on Earth, the closest thing they found did not belong to a human at all. It belonged to something else, a different kind of human, one that has been extinct for tens of thousands of years. If you stay with this all the way to the end, you'll understand something about our own origins that runs almost exactly opposite to most people's intuition. It has nothing to do with any group being stronger or older or more pure. What it actually is turns out to be stranger and quieter and far more human than that. If you like a real mystery followed all the way down to the bottom, consider subscribing, and let's take this one from the beginning. The people are the Tibetans. The place is the Tibetan Plateau, the highest inhabited landscape on the planet, a vast cold sweep of grass and stone and wind that the people who live there sometimes call the roof of the world. And the gene is called EPAS1. That is the promise of this story, stated plainly. A gene that lets the Tibetans live where the rest of us can't, and a discovery that its deepest origin is not fully human. But the plain statement hides everything that matters. To see why a single gene could make a room full of geneticists stop and stare, we first need to understand how human DNA normally works, because the surprise here only lands once you can see the baseline it breaks. Here is that baseline. Every human being alive is astonishingly closely related to every other. Line up the complete genome of any two people from anywhere on Earth, a fisherman in Portugal, a farmer in Laos, a nurse in Nairobi, and they come out something like 99.9% identical. Our entire species descends from ancestors who lived in Africa relatively recently, in the long arc of evolution. We are one young family that spilled out across a whole world, and the visible differences between us are a thin, shifting film stretched over an enormous shared depth. But that film is not empty. As our ancestors left Africa and pushed north and east into Europe and Asia, they were not the only kind of human on the continents they entered. There were others already living there. Older branches of the family who had left Africa long before and had changed over hundreds of thousands of years in the cold of distant lands. The most famous of these were the Neanderthals, and we now know that when modern humans met them, they did not simply push past them and replace them. They mixed with them, which is why most people alive outside of Africa today carry a small trace of Neanderthal DNA. A percent or two woven quietly into the genome, the genetic memory of a meeting tens of thousands of years old. So a faint thread of archaic DNA inside a modern person is not, by itself, a shock. That much was already understood before this story began. What happened with the Tibetans was something else entirely. Something that took that quiet, settled fact and turned it into a life-or-death advantage on the highest ground on. Start with the puzzle of the altitude itself, because it is stranger than it first appears. When an ordinary lowland body is starved of oxygen, it responds in a way that seems sensible. It makes more red blood cells to carry more of whatever oxygen there is. Climb a mountain, and over days your body quietly begins to do exactly this. In the short term, it helps, but held for years at extreme height, that same response curdles into a liability. The blood grows thick with too many cells. It moves more slowly. The heart labors to push it. This is the root of what's called chronic mountain sickness, a genuine, dangerous illness that can settle into the bodies of people who live too high without the right adaptations. The very reflex that rescues a climber over a weekend can, over a lifetime, become the thing that wears a body down. The Tibetans, on the whole, do something different. Their bodies do not flood the blood with red cells the way a visitor's would. They carry, on average, less hemoglobin than you'd expect for people living that high. And yet, they thrive. They deliver enough oxygen to their tissues without the dangerous thickening. They are, in a plain physical sense, at ease in conditions that would slowly grind another body down. When researchers went hunting for the genetic reason behind that ease, the trail led, again and again, back to a single place in the genome. To EPAS1, a gene that helps govern how the body senses oxygen and decides how to respond when there isn't enough. To find it, they did something simple and clever. They compared the Tibetans with their nearest lowland relatives, the Han Chinese, two populations who share a recent common ancestry, one living high and one living low. Whatever the mountain had changed should show up as a difference between them. And EPAS1 lit up like a beacon. But there was more. Because when Huerta-Sanchez and her colleagues measured how strongly this gene had been favored in the Tibetan population, they found one of the most powerful signals of natural selection ever recorded in a human group. This was not a gene drifting quietly along for the ride. This was a gene that had been so useful, so fast, that its beneficial version had swept through an entire people, carried forward generation after generation by the oldest arithmetic there is. Those who had it were more likely to live, and to raise children who lived, and to pass it on again. To put the scale of that in perspective, selection this strong is genuinely rare in our species. It is the genetic fingerprint of an advantage so decisive that it reshaped a whole population in what, on the clock of evolution, is barely an instant. Something up there was killing the people who lacked this gene, or quietly keeping their children from being born, and rewarding the people who had it relentlessly for a very long time. And when you ask how a gene gets favored that hard, that fast, the answer is quietly devastating. Selection this powerful usually works through the most fragile thing there is: babies. At extreme altitude, pregnancy itself becomes precarious. Thin air can mean lower birth weights and newborns who do not survive their first fragile months. Women who carried the Tibetan version of EPAS1 tended, on average, toward healthier pregnancies and stronger infants, better matched to the mountain air. Generation after generation, that difference decided, in the quietest, saddest way imaginable, whose children lived to grow up and carry the gene forward. The sweep through the population was never an abstraction on a chart. It was written, one birth at a time, in who made it through a first high-altitude winter and who did not. But even this was not the full story, because the team then looked closely at the exact version of EPAS1 that the Tibetans carried. Not just the gene, but the precise sequence of letters, the particular variant that had spread so far. And that variant was strange. It was not a small, tidy tweak of the ordinary human version. It was unusual, distinctive, unlike what almost anyone else on Earth was carrying. And it was too different and too complete to fit the easy explanation. A brand new mutation that had simply appeared somewhere on the plateau and spread. There had not been enough time. In the relatively short span since the ancestors of the Tibetans and the Han Chinese parted ways, a fresh mutation could not plausibly have become that distinct and swept that far. The math did not close. So where had it come from? And the deeper they looked, the stranger it became. They searched. They held the Tibetan version of EPAS-1 up against the genomes of population after population around the living world, looking for anyone at all, who carried something like it. And they came up almost entirely empty. In the whole of the living human species, this particular variant was, for all practical purposes, found in exactly one place, among the Tibetans themselves. Until they compared it against a genome that did not come from anyone living at all. A few years earlier, in 2010, scientists had done something that sounds like it should be impossible. In a cave in the Altai Mountains of southern Siberia, a place called Denisova Cave, they had found a small, unremarkable fragment of a finger bone. And from that fragment, they had pulled ancient DNA. When they read it, the sequence did not match a modern human. It did not match a Neanderthal either. It belonged to a previously unknown kind of human, an entire distinct branch of our extended family that no one had known existed. Nobody had gone into that cave looking for a new kind of human. They had expected the bone to be one of the two they already knew, a modern human or a Neanderthal, the only options anyone thought were even on the table for that time and place. Instead, the DNA answered with a third thing. A stranger in the family tree, hidden in plain sight inside a single fleck of finger bone, waiting through all those millennia in the cold for someone to finally read it. We call them the Denisovans, and this is the haunting part. We still know them almost entirely through their DNA. Physically, they left behind next to nothing. That finger bone, a scatter of teeth, a few other fragments. We have never found a Denisovan skull. We cannot say with any confidence what their faces looked like. An entire kind of human, and we know them mostly as a genome recovered from the dark of a cave. When Huerta-Sanchez's team laid the Tibetan version of EPAS-1 alongside the Denisovan genome, the match was there. The distinctive variant that lets a Tibetan body live in peace on the roof of the world was, in its deepest origin, Denisovan. Think about what that means for a moment. Tens of thousands of years ago, the ancestors of modern Tibetans crossed paths with these other humans, the Denisovans, and mixed with them the same way our ancestors mixed with Neanderthals. In that mixing, a version of EPAS-1 crossed over from one kind of human into another. And for a very long time afterward, it was probably nothing special at all, just one variant among many, carrying no particular weight, drifting quietly through the generations. It was, if you like, a loan from a vanished neighbor. A key handed across, long before there was any lock it was meant to open. And then, much later, a group of humans who happened to be carrying that key climbed up onto the highest plateau on Earth. And there, at last, the door appeared. In that thin and punishing air, the old Denisovan version of the gene turned out to be precisely the thing a body needed. It helped. It kept people alive. It let their children be born and grow. And so it spread, driven through the whole population by the simple, patient force of survival. The Tibetans' gift for the heights is entirely real, but it was, in the most literal sense, inherited. A fragment of a lost people, kept alive inside a living one. It is worth sitting for a moment with who the Denisovans were, because it only deepens the strangeness of all of this. We have no portrait of them, no language, no name they called themselves, no image of a Denisovan face looking back at us. Almost everything we understand about an entire branch of humanity, we understand because of the DNA they left inside people who are alive right now. They are a species written, for the most part, in the past tense, and yet not completely, because a piece of them is still here, still working, still doing something useful in the world. And EPAS1 is not their only trace. Denisovan DNA turns up in other living populations too, carried in larger amounts by people across the islands of the Pacific and parts of Southeast Asia, where some groups carry several % of their genome from this vanished lineage. That, on its own, was a revelation. It meant the Denisovans had once ranged far more widely than a single Siberian cave could ever suggest. Across thousands of kilometers, into warm, distant lands, leaving their mark in peoples who live an ocean away from the Altai. The map of where the Denisovans actually reached is still being drawn, and the Tibetan discovery redrew a piece of it. Hard evidence of that lost people's presence, pressed into the genes of a mountain population living far from any cave we've ever dug. There is something almost unbearable about it, if you let yourself feel it. A kind of human we would otherwise call extinct is not entirely gone. It persists. Not as bones behind museum glass, but as a living instruction inside living bodies, helping a child on a high, cold plateau draw an easy breath from air that would leave the rest of us gasping and dizzy. Now, here's the part that is easiest to get wrong, and it is the most important part of the entire story. It is tempting to read all of this as a tale about one group of people being specially equipped. Tougher, better built, a superior stock forged by the mountain. It is a tempting reading, and it is simply wrong. And the remarkable thing is that the science itself is what corrects it, from several directions at once. Start with where the gene came from. It is not a Tibetan invention, and it is not a badge of some inner strength. It is a Denisovan inheritance, a variant that arrived by pure chance through an ancient meeting that no one chose, tens of thousands of years before it was ever the slightest bit useful. Nobody earned it. Nobody willed it into being. In the plainest possible terms, it was a demographic accident that happened much later to fit a place. Now notice what the gene actually does. It does not make a body stronger or faster or better in any general way. Take a Tibetan and their EPAS1 variant down to sea level, and it confers no grand advantage at all. None. The gene is not an upgrade to the human machine. It is a fit. A quiet match between one particular variant and one particular punishing environment. Change the environment, and the whole advantage simply evaporates into nothing. You can see this most clearly by looking somewhere else entirely, to the other side of the planet. High in the Andes of South America, other human populations have also lived for thousands of years at tremendous altitude. They too are adapted to thin air. But they solve the problem in a different way, through different genetic changes along a different path, and without the Denisovan variant at all. Two peoples, two great mountain ranges, two entirely separate answers to the very same hard question. There is no single ladder here, with one group standing higher on it than another. There are different solutions, each shaped by a different history, each of them just a way of belonging to a particular corner of the earth. So the honest reading of the Tibetan genome is not the story of a stronger kind of human. It is the story of how tangled and how shared our origins really are. We like to imagine ancestry as a tree. Clean branches splitting neatly apart, each group its own separate line running back into the past, never touching the others. The truth that the Denisovans keep forcing on us is that it looks far less like a tree and far more like a web. Branches that were supposed to be separate reach back across the gaps between them and touch. Genes cross between kinds of humans we assumed had nothing to do with one another. And what lives in one people can turn out to be a gift, quite literally a physical inheritance handed over from another. And if you have ever taken one of those ancestry tests and seen a small, unexplained sliver of something ancient in your own results, a fraction of a percent attached to some strange, archaic-sounding name, this is part of what that is. It is the residue of the same deep story written faintly into you. All of us, everywhere, are mosaics of the peoples who came before, including some who are no longer here to be counted among the living. There is a quiet kind of persistence running underneath this whole story that is easy to miss on the first pass. The Denisovans as a people are gone. They left almost nothing behind. A sliver of finger, a scatter of teeth, a cold cave in the mountains. By every ordinary measure we have, they slipped off the face of the earth a very long time ago, and took their names and their faces and their voices with them. And yet something of them survived. Not the things we usually mean by survival, not a monument, not a bloodline anyone could point to, memory, but a single instruction handed to another kind of human at a chance meeting in deep prehistory, which then waited in the dark of the genome for tens of thousands of years, meaning nothing, doing nothing, until the moment it was finally needed. And in that moment, it kept a whole people alive on the roof of the world. That variant, that loan, that key passed across long before the lock existed, is still being copied today. In every Tibetan child born to easy breathing at 4,000 meters, a lost people's last and best gift is quietly at work, still keeping someone alive long after everything else about the givers has fallen into silence. That is the real discovery hidden inside the Tibetan genome. Not that one group of people is stronger than another. Read carefully, the science says almost the opposite. But that the line between us and the humans who came before, and the lines between one people and the next, were never anywhere near as clean as we imagined them to be. We are a web, not a row of separate branches. We are all, in part, made of others. And every so often, when we look closely enough at the thing that keeps a person breathing easily on the highest ground on earth, we find the fingerprints of a people who have been gone for longer than we can comfortably imagine, and who, in the only way still left to them, are somehow, quietly, astonishingly, still here. If this is the kind of story you want more of, real studies, real names, followed all the way down to the bottom, then you know what to do. Thanks for staying to the end.